Good morning, students. Once again, welcome to my class. Now, it is the third class of the periodic classification. Though the chapter is very small, and therefore only 2-3 classes are enough to complete the chapter. And moreover, question answers need one more classes. Now, in my last class, I have explained what is valency, what are the periodicity of valency, how valency changes along a period and in a group from top to bottom. Now, many more periodic properties are there, just like atomic radius. Atomic radius, sometimes it is referred to as atomic size also. Atomic size. Next one is ionization potential. Ionization potential or ionization energy. Then electronegativity, then electron affinity, then metallic and non-metallic properties. So these are some periodic properties. We have to discuss all these things. Now, out of these things, in your syllabus, atomic size is included or atomic radius, then metallic and non-metallic properties. These two are included along with valency. Now, these things are not given in your syllabus, and therefore we should read it. But still, I will give you some sort of idea about these topics also. What are these periodic properties? Now, let us start from atomic size. Atomic size or atomic radius. In your book, it is written as atomic size. Now, atomic size can be measured on the basis of atomic radius. What is atomic radius? The distance from the nucleus to the outer orbit electron is called atomic radius. Further, this atomic radius is divided into 4 types. Number 1, ionic radius. Number 2, covalent radius. Number 3, metallic radius. And number 4, van der Waals radius. So these things are also excluded from your syllabus. These things are not present. Just simply the distance from the nucleus to the outermost orbit electron is called atomic radius. That is required. That means if it is a nucleus, say 3 orbits are present or orbitals are present in the atom, then the last orbit electron, this distance is known as atomic radius, and on the basis of that, atomic size is measured. Now, the unit of atomic radius is picometer. Its unit is picometer. 1 picometer is equal to 10 to the power minus 12 meter. 1 picometer is equal to 10 to the power minus 12 meter. Now, the atomic radius for hydrogen atom is 37 picometer. For hydrogen, the atomic radius is equal to 37 picometer. Atomic radius is 37 picometer for hydrogen atom. Now, what is the periodicity of atomic size or atomic radius? What is the periodicity? periodicity of atomic radius or atomic size. What is the periodicity? Number one, in a period, when we move or when we move from left to right in a period, when we move from left to right in a period, due to increase in the number of nuclear charge. Nuclear charge means proton. The charged particle only present in the nucleus is proton, and therefore nuclear charge means the number of protons present in the nucleus. That is known as nuclear charge. In the nucleus, neutrons are also present, but these neutrons are chargeless, and therefore atomic nuclear charge cannot refer for neutrons. So, in a period when we move from left to right, due to increase in the number of nuclear charges, atomic size, atomic radius or atomic size gradually decreases, but in a group you can write down the group due to increase in the number of cells, atomic radius or atomic size gradually increases. Atomic size by atomic radius to gradually group eta upor ba tollai goi thakile ki hobo bahi goi thakibo. Why? Because the number of cells gradually increases. Now next topic is metallic and non-metallic properties. Metallic or non-metallic property to be. How you can explain what is metallic property? That is how easily one atom can release electron. That is the measure of atomic, that means metallic property. If some element can release electron easily, then its metallic property is more. It is more metallic. But if it cannot readily release electrons, then its metallic property is less and non-metallic property is more. But the metallic property depends on how easily one element can release electron. Electron kiman সহজে এৰিব পাৰে. গতিকে তোমালোকে যদি চাই যোৱা in the periodic table, alkali, let us consider alkali metals: lithium, sodium, potassium, rubidium, cesium, francium. এখানে যদি তোমালোকে চোৱা তেনেহলে from top to bottom, উপৰ পৰা তললৈ, metallic property increases. Metallic property increases. Why metallic property increases? Because the atomic size increases. Atomic size to বাঢ়ি আহে. ইয়াত দুটা সেল আছে, ইয়াত তিনটা আছে, ইয়াত চাৰিটা সেল আছে, এনেকৈ সেলবিলাক বাঢ়ি গৈ আছে। গতিকে সেলবিলাক বাঢ়ি যোৱাৰ লগে লগে তাৰ সাইজটো ডাঙৰ হৈ গ'ল, আৰু সাইজটো যেতিয়া ডাঙৰ হৈ যাব, সাইজটো ডাঙৰ হৈ যোৱাৰ লগে কি হ'ব? সিহঁতৰ ইলেক্ট্ৰনটো নিউক্লিয়াছৰ এট্ৰেকশ্যনৰ পৰা আঁতৰি গুচি যাব, বেছি ডিষ্টেন্সত থাকিব। গতিকে নিউক্লিয়াছৰ আকৰ্ষণৰ পৰা ইলেক্ট্ৰনটো আঁতৰাই নিবলৈ বেছি ইজি হৈ যাব। গতিকে সেইটো কথাৰ কাৰণে মেটালিক প্ৰপাৰ্টিটো বাঢ়ি যায়। কিন্তু নন মেটালিক প্ৰপাৰ্টি কি? নন মেটালিক প্ৰপাৰ্টি উল্টা হ'ব। গ্ৰুপ এটাত নন মেটালিক প্ৰপাৰ্টি গ্ৰেজুৱেলি ডিক্ৰিজ হ'ব। So non-metallic property increases, but non-metallic property gradually decreases. Period but key. Let us consider a period. Period আমি বলেছি সোডিয়াম প্রপার্টি বলেছি সোডিয়াম মানে আমি লিথিয়াম হাইড্রোজেন লিথিয়াম বেরিলিয়াম বোরন কার্বন নাইট্রোজেন অক্সিজেন fluorine neon. It is the second period elements these are second period elements. A second period elements are what আমি যদি metallic properties are in metallic properties decrease হয়ে যায় along a period metallic property gradually along a period metallic property gradually decreases but non-metallic property gradually increases. Metallic property gradually decrease hobo and non-metallic property gradually increase hobo. Eta kihor karone hoy kiyo এইপিনে আমি গৈ থকাৰ লগে লগে নিউক্লিয়াৰ চাৰ্জ বাঢ়ি যাব নিউক্লিয়াৰ চাৰ্জ বাঢ়ি গলে হেতৰ আউটাৰ মোষ্ট অৰবিটত যদি ইলেক্ট্ৰন থাকে সেই ইলেক্ট্ৰনটো কেতে ৰিলিজ কৰিব নিবিচাৰে ইলেক্ট্ৰনটো যদি ৰিলিজ কৰিব নিবিচাৰিব তেতিয়া তাৰমানে ইট cannot release electron easily so its metallic property decreases and hence non-metallic property increases সেইকাৰণে তোমালোকে নিজে চাবা কথা হয় যে এইবিলাক fluorine it is a non-metal oxygen non-metal nitrogen non-metal carbon is a non-metal so these are non-metals but in this side lithium beryllium boron these are their metallic property is high is it clear I think these things are pretty clear to you now actually your chapter is finished complete it is but still I want to explain you a few things. First of all, what is ionization energy? Ionization energy. The amount of energy required to release the most loosely held electron from an isolated gaseous atom in its neutral state to convert it into a cation is known as ionization energy or ionization potential. Sometimes it is also referred as ionization enthalpy. ডাঙৰ ক্লাছলৈ গৈ থকা লগতে তোমালোকে কথাবিলাক বেলেগ বেলেগ ধৰণে গম পাই গৈ থাকিবা এতিয়া ইয়াত আয়নাইজেশ্যন পটেনশিয়াল বা আয়নাইজেশ্যন এনথালপি এই বস্তুটো আমি কলো কিন্তু তাকে এটা ডেফিনেশ্যন দীঘল ডেফিনেশ্যন কৈছো যেটো তোমালোকৰ কাৰণে অকমান টাফ হ'ব পাৰে নাও এই বস্তুটোকে আমি অকমান সহজভাৱে যদি পাতো একেবাৰে সৰুকে যদি আমি সহজভাৱে পাতো তেলে কথাটো কি যে from the nucleus the electrons are attracted by the nucleus. Let us consider an electron which is present in the second orbit of an atom and the nucleus is present inside. The electrons are strongly attracted by the nucleus and therefore to remove this electron from that nucleus a definite amount of energy is required. In nucleus to electron to operate a definite amount of energy লাগিব and that energy is known as ionization energy. Aru simple ke koisu electron to operate dibole yar attraction or energy lage সেই এনার্জিটো লে কনভার্ট কি এনার্জিটো দিলে এই আয়নলে কনভার্ট হয় যেনে ধৰা সোডিয়াম আছে 281 এটা ইলেক্ট্ৰন আঁতৰি গ'ল তেতিয়া Na প্লাস হ'ল আয়নলে কনভার্ট হ'ল যেটো এনার্জি তাৰ কাৰণে লাগিব এনার্জি that energy is known as ionization energy that energy is known as ionization energy is that clear now next what is electronegativity electronegativity. The definition of electronegativity tells us that the relative tendency to attract the shared pair of electrons towards itself. The relative tendency to attract the shared pair of electrons towards itself শেয়ারিং হৈ থকা ইলেক্ট্ৰনটোৰ নিজৰ গাৰফালে টনাৰ যে আপেক্ষিক প্ৰৱণতা তাকে ইলেক্ট্ৰনেগেটিভিটি বুলি কয় সে ফৰ এক্সাম্পল HF molecule এটা মল মানে দুটা ইলেক্ট্ৰন মনত ৰাখিবা one mole means two electrons now HF molecule in the HF molecule two electrons are present in between fluorine and hydrogen it should be present in between them completely in between them in the middle but due to the fact that fluorine has greater tendency to attract the shared pair of electrons towards itself. Fluorine gets delta negative charge, partial negative charge, and hydrogen carries partial positive charge. Now, this relative tendency is known as electronegativity. Okay, relative tendency to be electronegativity বুলি কওঁ আৰু electron affinity to কি বস্তু ইলেক্ট্ৰন তাক নিজৰ গাৰফালে টানি লোৱাৰ যিটো ৰিলেটিভ টেন্ডেন্সি সৰি নিজৰ গাৰফালে নিজৰলৈ ইলেক্ট্ৰনটা কমপ্লিটলি লৈ ল'বলৈ যাওঁতে এনাৰ্জি ৰিলিজ হয় যেনে মই কৈছো যে আয়নাইজেশ্যন এনাৰ্জি ক্ষেত্ৰত যেতিয়া এটা ইলেক্ট্ৰন আমি কমপ্লিটলি ইলেক্ট্ৰন এটা উলিয়াই নিবলৈ যাওঁ কামাৰ আকৰ্ষণৰ পৰা কিবা এটা বস্তু অঁতৰাই নিবলৈ যাওঁতে এনাৰ্জি লাগে কিন্তু যদি আমি কিবা এটা বস্তু ভৰাই দিওঁ তাৰ পৰা এনাৰ্জি ৰিলিজ হয় এটা ইলেক্ট্ৰন এফিনিটি টু হেতু বস্তু যেতিয়া কি ইলেক্ট্ৰনটা লৈ লয় তাৰ পৰা এনাৰ্জি ৰিলিজ হয় and that energy is known as electron affinity so theoretically this chapter is finished so in my next class I will discuss about some problems of the chapter and students please do come to the doubterance classes thank you